Hello all. In this session, we are going to discuss about the addresses used in TCP IP model. In the last session, we have seen that there are four types of addresses used in TCP IP model, namely MAC address, which is the lowest address in the TCP IP model. MAC address is also known as physical address or hardware address. At the network layer, we have IP address, which is nothing but logical address. At the transport layer, we have port addresses. And at the application layer, we have special addresses or URLs. In this session, we are going to see the significance and uses of these addresses. As you can see on the slide, MAC address is used for hop-to-hop data transfer. IP address is used for host-to-host data transfer, and port addresses are used for process-to-process data transfer. Now we will see the uses in detail. We already know that the boundary of a LAN is a router. So when a machine used in one of the rooms in probably a building or in a LAN, the data that is transferred from that machine will go to the nearest switch. From the switch, it will go to the router, which is a boundary of that LAN, and then the data will be transferred to the outside world. During this data transfer, which addresses are used and relevant, that we will see in the given diagram. We have PC A and PC B. PC A wants to send some data to PC B, which is in another LAN. So please understand, when two machines are in different LANs, they are connected to different routers. So PC A's data will go to switch A. Eventually, it will be given to router A, which is a boundary of the LAN A. After some routing process, it reaches the router B, which is the destination router. From router B, it will be given to the switch B, and from there it will be delivered to PC B. This is the whole scenario of the communication. Now, which addresses will be used at which level? We all know it is a logical thing. We all know that MAC addresses are used at the host to network layer. Speaking about ISO OSI model, it is used at data link layer, whose physical device is a switch. So switches operate on MAC addresses because switches operate at the data link layer. Please understand that I am talking about ISO OSI model reference. Then we have a router which communicates with another router, and both the routers operate at the network layer. The addresses that are handled by the network layer are logical addresses, that is IP addresses. So router to router communication takes place with the help of IP address, whereas switch to PC or switch to router communication takes place with the help of a MAC address. So from PC A to switch A, the data transfer will take place with the help of a MAC address. Switch A to router A, again MAC address. Now here we need to understand that router has LAN side as well as WAN side. So router's LAN card operates on MAC address and router's WAN card operates on IP address. Router to router with IP address, router to switch again MAC, and then to PC again a MAC address. So this is the flow of communication and corresponding addresses used. Here we need to understand that when the data transfer is taking place from PC to a switch, during this, the MAC address of the data packet has two fields, source MAC as well as destination MAC. So during this data transfer, source MAC will be MAC address of PC A and destination MAC will be MAC address of switch A. When the data comes to switch A, now for this data transfer, source MAC of the data packet will be switch A MAC and destination MAC of data packet will be router MAC. So here you might have observed that source and destination MAC addresses during this transfer and during this transfer are different or changed. So in every step, at every step, the MAC addresses are changed. Same is the case for this communication also. And that is why we call the MAC address as hop-to-hop address. Because the MAC address changes every hop. On this slide, we can see MAC address is called as hop-to-hop address. IP address is host-to-host address because during this communication, IP address of the data packet does not change. From the source, which is PC A, to the destination, PC B, IP address of the data packet, source field as well as destination field, IP addresses do not change. So IP address is known as host to host address. And then we need to understand the significance of port address. Port address is also known as process address. We know that at a time on a machine, we have multiple processes running. So to identify each process independently, we need to have some unique identification for each process. And that address is known as process address or port address. Now let us consider a scene. We have a sender whose name is Alice and we have a receiver who is Bob. On Alice, there are two processes running, which is app1 client process and app2 client process. We can take an example of two different games. You wish to simultaneously play two different games, then app1 will be game 1. You're requesting, so you will be a client, and app2 client is game 2 client process. So we have two different processes running on the same machine. And then Bob, which is a server for app1 as well as app2. Now the two requests from Alice have to reach Bob separately. There is an internet or web in between. So obviously the routing process will be followed, and through the routing process, the app1 request and app2 request will go to app1 server and app2 server. But on the whole, it looks like Alice is sending two different requests to Bob. So main task is to reach or to successfully deliver those two requests from Alice to Bob. So what app1 and app2 client do, they send their request to the Alice. This is nothing but application layer of Alice. Using the usual process, Alice sends two different packets. One is FTP. FTP and HTTP are two examples that I have considered. You can consider it as app1 and app2. So there are two packets sent. One is app1 request and another is app2 request. Through the routing process, the two packets reach Bob. So there are two different packets which will reach Bob. Now at the Bob, Bob has to decide which request to deliver to which app, because app1 request has to go to app1 server and app2 request has to go to app2 server. And here we have a role of port address. Using the port addresses given in the data packet, which is received at the Bob, Bob realizes that, okay, this port address belongs to app1 process. So let me deliver this packet to app1 and the other packet to app2. And so this is how the data packets are delivered not only to the host Bob, but to the appropriate processes that are running on that particular host. I hope the idea of process to process communication is clear. So we have hop to hop communication, which is at every step. At every step, MAC addresses of the source and destination changes. And so MAC address is used for hop to hop communication. Throughout the communication, IP address of the source and destination do not change. And hence, IP addresses are known as host to host address. And it is used for host to host communication. And port addresses, which are nothing but process addresses, are talking to each other, like peer-to-peer process we have already discussed. So port addresses are used for process to process communication. This is all about the addresses used in TCP IP model. Here are a few questions for you. Is port address physical or logical? To find the answer, please refer to the last video. We have already discussed why MAC address is called as physical and IP address is called as logical address. Using the same logic, you can answer this question whether port address is physical or logical. Second question is, if you are sending an email to your friend in the US, how many times the IP address of the source or destination shall change in the whole communication? Whatever your answer is, please try to find out justification for your answer. We have come to an end of this session now. We will stop the session. Thank you.